Hello again, it's your favourite maths teacher, the only one you've got I suppose. With the last thing we need to talk about, because there is a question like this in the book on the work that I've set, and also because it tends to be a classic exam question. And it's the kind of exam question that you want to get in the exam because it is very easy to get the marks, but yet somehow, for some reason I cannot get my head around, students usually drop marks there. And it's a very stupid question to drop marks in, because what you have to do is very, very simple, so long as usual, you listen to me. Which, I know in some cases, you're not even going to bother listening to me, but hey ho, here we go. So, sometimes, in the exam they will ask you to compare two data sets. Just compare them. And typically these questions are worth 2 marks, because in the comparison you have to talk about two different things. And the two things that you need to talk about, and you need to make the appropriate comparison, is, first mark, compare a measure of average between the two data sets. And what measures of average do we know? Mean, median, and mode. But typically, more often than not, you're going to be talking about the median, because this is given in the context of cumulative frequency diagrams or box plots or whatever. But anyway, you're going to be talking about the median, you're going to compare the average. So your first comparison point should begin with the magic words, on average, blah blah blah. And the other point of comparison that you should make is in reference to the spread. So compare the spread of the two data sets. And what measures of a spread do we know by now? Well, we know the range, but we also know the interquartile range. And again, typically it doesn't matter which one you use, but as we discussed in the previous video, the range is more susceptible to extreme values. The interquartile range may give you a more reliable indication of consistency in the data. These things, as usual, better seen through an example. So here we go. Here I've got some data, very traditional, very boring, comparing boys and girls. These could be the results of your last exam. So the median for the boys was 30%, median for the girls was 35%. The maximum score for the boys was 55, for the girls 65. The minimum score for the boys was 18, minimum for the girls was 10. The upper quartile for the boys was 35, is that 35? Yep. Looking at upside down, and the upper quartile for the girls was 40. Lower quartile for the boys was 25, for the girls was 20. If they're nice in the question, they'll give you the data. If they're not very nice, you may have to calculate it beforehand, okay? Right, so, myself, Mr. Salinas, how would I answer this question if they asked me to compare the distribution of results between boys and girls? For the first mark, I would say, on average, the girls did better because the median, 35, is higher than the boys' median of 30. End of story. That simple, that is it. On average, the girls did better because their median, 35, is higher than the boys' median, 30. That's it. Now, for the second mark, I need to talk about spread, okay? And if you can, whenever you can, go to the interquartile range, okay? I haven't got it here, but I can calculate it because we know how to do that. So, the interquartile range for the boys is going to be 10, and the interquartile range for the girls is going to be 20. So, for the second mark in this question, I would say that the boys were more consistent than the girls, because if we look at the interquartile range, the difference was only 10. So for the middle 50%, for the most representative 50% of the boys, the results were more compact, were more together, were more similar than they were for the girls, because their interquartile range was 20, was higher. So the girls' results were more spread out for the middle 50%, because we are looking at the interquartile range. An option that you could do, that you could have, is talk about the range as a whole as well for the second mark. So for the second comparison point, you could find the range for the boys, which is 37. So let's write it down. And the range for the girls was 55. So I suppose in this case, both when you look at the range and when you look at the interquartile range, you come to the same conclusion, that the boys were more consistent. Overall, because their range is smaller than the girls, but if we look at the middle 50%, the most representative 50% of the data, the boys were more consistent than the girls as well. A few notes, a few things to bear in mind. It is not necessarily going to always be the case that because the range is smaller, the interquartile range is also going to be smaller. That's not necessarily true. I could have a 30 here, or I could have a 25 here and a 20 there, and these numbers don't change. Okay? So that's not necessarily the case. Please, 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 please do not, I repeat, do not do the following in the exam. Do not compare the highest point of the boys with the highest point of the girls. And please, please, please do not compare the lowest point of the boys with the lowest point of the girls. Those things don't get you marks, okay? Some people start writing, the highest for the boys was whatever, and the highest for the girls was whatever, but no. It is very simple. Remember, 1 mark, comparing a measure of average, the median. Another mark, comparing 1 measure of a spread. Preferably interquartile range, but you could do the range as well. Reference the values in your answer and you will be absolutely fine. Okay, so fantastic. Thank you for watching. 3 videos on 1 day. I'm on a roll. Please do the work. I'm expecting answers, questions. Take care. Wash your hands. You've got work to do. You shouldn't be playing Fortnite. See you next time. Bye.